Hello everybody, it is now week 3 of our remote learning. This week what we're going to be talking about is gravitational potential energy. So the first lesson we did was just on energy in general, just starting that discussion. Last time we talked about kinetic energy, just kinetic energy, and this time we're going to just talk about gravitational potential energy. Okay, so let's get right to it. So a little bit of review. Gravitational potential energy is energy that is stored. Any kind of potential energy, because gravitational is not the only one of them. It's the only one that we will focus on, but it's not the only one. So any kind of potential energy is energy that is stored. This one is gravitational. So where's that energy stored? That energy is stored in gravity. So gravitational potential energy is energy that is stored in gravity. So imagine hold a water balloon above the ground off the top of the school bleachers. Gravity could and will cause the balloon to speed up towards the ground, right? But not until we let go. So energy is there, but we don't see it until we let go. Once we let go, it starts moving and we can actually see that energy. But as long as when we're holding it, it's not moving it. So we don't see that energy, but it is there. Gravitational energy depends on height. The higher an object is from the ground, the more gravitational potential energy it has. And it also depends on mass. More mass means more energy. So that is stuff that we talked about a couple weeks ago in that first energy video, but just bringing it up here again just as a refresher. Okay, so kind of like last time with kinetic energy, reminded you of what it was, and then we talked about the math for it, and that's kind of what's happening here. We just went through a reminder of what gravitational potential energy is. Now I'm going to give you the equation. That equation is GPE, is gravitational potential energy, equals m times g times h. M stands for mass, and as always, we measure mass in kilograms. Abbreviate that with a kg, because who likes to write kilograms a bunch of times? Not me. GPE stands for gravitational potential energy. Just like all kinds of energy, it's measured in joules. All energy is measured in joules, including gravitational potential energy. And we abbreviate joules with a J. G is the acceleration of gravity, and because that's an acceleration, it's measured in meters per second squared, or m divided by s squared for short. On Earth, that's our usual 9.8 that we've been seeing for a while now. Actually, ever since we came back from winter break, we've been seeing 9.8, and there it is again. H stands for height, and that's a distance, so we measure that in meters and abbreviate meters with an m. Okay, the one little thing here that is an important detail is that the height should be measured from whatever the object will land on. That could be the ground, but it doesn't have to be. For example, you could hold a textbook above a desk, right? And for H, I would measure how far the textbook is above the desk, not above the ground. Okay, so let's do a couple examples. I got 4 examples, and we're done. So finding gravitational potential energy. These first 2 examples, both of them, we're just going to plug in and find the gravitational potential energy. So for example 1, I want to find the gravitational potential energy of a 2 kilogram object that is 5 meters above the ground. So here's our gravitational potential energy equation. GPE equals mgh, m times g times h. And they told us that our mass is 2 kilograms. Our kg, that should tell you right there, the kg tells you that that's mass, so that goes in the m spot. And the 5 meters, 5m, above the ground, that's a height, so that goes in the h spot. And then g, just like I mentioned on the last slide, is 9.8. Okay, so g is 9.8, just like it has been for the whole forces unit. So 2 times 9.8 times 5, you should get 98 joules of gravitational potential energy. This is energy, so the unit should be joules right there. Okay, let's do another one. Find the gravitational potential energy of an 8 kilogram object that is 4 meters from the floor, but it's being held above a desk that is 1 meter tall. Okay, so we're still using the same equation. GPE equals mgh, gravitational potential energy. So, but this time for h, we're gonna have to do some subtracting here. because 4 meters is from the ground, but it's not going all the way down to the ground. It's above a desk, so it's going to stop. It's going to hit the desk and stop there. And the desk is 1 meter tall, so it's not going to go 4 meters down to the ground. It's going to go 4 minus 1, and that's 3. So 3 goes in the H spot right here. G is 9.8, like it always should be. And then M, they told us that our mass is 8 kilograms. So M is 8, so put 8 in the M spot. And then just multiply to get the gravitational potential energy. 8 times 9.8 times 3. And from that, you should get 107.8 joules of GPE, gravitational potential energy. Okay, but what if you aren't just trying to find the gravitational potential energy? Maybe we know that. We need to figure out one of the other things. So then what do we do? So these are a couple examples for if you're going to find the mass or find the height. So for example, 3 here, a 7 kilogram object has 250 joules of gravitational potential energy. I want you to find the object's height above the ground. So here's our equation, GPE, gravitational potential energy, equals mgh, m times g times h. And GPE, they told us that our energy was 250 joules, and they also told us the mass, it's 7 kilograms. So 7 kilograms goes in the m spot, because that is mass, and we know that because they put kg, that's mass. And then in the equation, g is 9.8, once again, and h is what we're trying to figure out. They want us to find the object's height above the ground. So h, we don't know h, we're trying to figure that out. So that stays h. So the first thing I'm going to do is multiply 7 times 9.8. 7 times 9.8 is 68.6. Notice everything else stayed the same. Nothing else happened. We're trying to get the h by itself. So what do we got to do? We got to divide. H is 250 divided by 68.6. And what do you get? You get 3.64. And that is in meters because we're calculating the height here. Height, that's measured in meters. Okay, let's do one more. It's the last one. An object has 90 joules of gravitational potential energy when it is 3 meters above the ground. Find the mass of the object. So, same equation. GPE equals m times g times h. 90 joules of gravitational potential energy. So 90 joules, 90 goes in the GPE spot. And 3 meters above the ground, so that's a height. So 3 meters goes in the h spot. 90 for GPE, 3 goes in the h spot. G is 9.8 like it should be. And m is what we don't know. M is that's the mass. We're trying to find the mass. We don't know the mass. So that doesn't turn into a number. That's what we're trying to get. It stays in m. So then we're just going to multiply 9.8 times 3. Everything else stays the same. Oh, I left an h there. That should be an m. 9.8 times 3 is 29.4 times 29.4 times m. That's an m. Okay. And we just got it to get m by itself now. Now we just got to divide. M is 90 divided by 29.4, and 90 divided by 29.4 is 3.06 kilograms. So the mass, we measure that in kilograms, and 90 divided by 29.4 is 3.06. Also, be prepared that you might have to do the height thing, like if it's above a table or a counter or a desk. For a problem like that, you might have to go backwards, right? So be prepared that for gravitational potential energy, like we did in example 2, you'll have to subtract those heights. But if you're going backwards in that problem, you might have to add the height back in. Like if you know the height above the desks, but I want the height above the ground. So just be aware that is going to be in there. There's definitely going to be a problem or two where you're going to have to think about that backwards. Other than that, that is it. That's all we got. As usual, the same as the last couple of weeks, you've got some follow-up questions to do on Go Formative. So get those knocked out. Hope those go easy for you. If you have any trouble, though, of course, as always, feel free to shoot me an email. Make sure you email me at my .org account. So that's nchristopher@plano88.org. Make sure you use the org account because that's the one I'm checking. But yeah, if you need anything, just send me an email. All right, now I'll see if I can help you out. All right, everybody, take care.